When I finish a unit, especially Unit 4, I partake in some delicious Dunkin' Donuts coffee. Hot? Ooh, gotta love it. Mr. Key here to help ye. By the way, hit the subscribe button, please. Miss Newman and I would so much appreciate it. Thank you very much. All right, let's get going. Chapter 4 test. Now, subtracted from, we're going to take this one, and we're going to subtract it from this one. So this one comes first. 6x cubed minus 10x squared minus 3x minus 6 minus. Now, we're subtracting off this whole thing. Okay? That's kind of why we need these parentheses. Minus 4x squared. I'm going to show you how I would do the problem in a minute. At the junior level, at the high school junior level, the way I would do it. 3x and then minus 10. All right, so here we go. Oops, grabbed the wrong pen. We're going to turn this, we're going to distribute this. So this becomes a plus, this becomes a minus, and this becomes a plus. So there's only one x cubed, so I'm going to go 6x cubed. No, Miss Corvette, I'm not going to do the Corvette way of doing this. It's too weird. I'm going to negative and positive, and it's from like 8th grade. Minus 6x squared, minus 3x, and minus 3x make minus 6x, minus 6, and positive 10 make positive 4. There is your answer. Now, how would I do this if I was going to do this at the high school level? Here's the way I would do it. I'd be like, all right, dude, seriously. We're going to take this thing, and we're going to subtract this thing from this. All right, well, this is the thing that's being subtracted. Okay, that turns into a positive. That goes negative, and that goes positive. So, because this is the thing that's being subtracted. So I'm just going to subtract it. That's all I'm going to do. So I take this 9x cubed, and I'm going to subtract off, but wait a second, I'm subtracting off a negative, which really means adding. So 10x cubed. Negative 2x squared, negative 9x squared, minus 11x squared, plus 3, minus 2 plus x, minus 10 plus 1 minus 9, catching my answer. Now, if this is a part 2 question, you really should show more work than that. This would be like the Maverick way of doing problems and the Krause way of doing problems, which is kind of scrappy, but you should be doing them with showing a little bit of work. All right, product. Product means multiply. So we're going to take this 3x squared minus x minus 4, and we're going to multiply it by 2x minus 3. That means there's going to be 6 multiplications and a little bit of addition to do. So we're going to multiply this times this, and this times this. So 3x squared times 2x is 6x cubed. 3x squared times negative 3 is minus 9x squared. Now I'm going to grab my blue pen. I'm going to multiply this times this. Negative x. Now be careful. This is where the signs have to come with it. This is negative x times positive 2, which is negative 2x squared. And negative x times negative 3, which is positive 3x. Grab my next pen. Orange. Negative 4 times 2x is negative 8x. And negative 4 times negative 3 is positive 12. Combine like terms. Okay, I'll do this one in good old black. 6x cubed. Let's see, negative 9 and negative 2 make negative 11x squared minus 5x plus 12. Now, I don't have an answer key with me today, so there's a real good chance I'm probably going to make a mistake or two. But I want to try to eliminate that because I don't like giving out bonus credit for mistakes. So what I'm going to do is I'm going to take some number. Let's take some obnoxious number like 2.13, and I'm going to store it into x. And my original problem was 3x squared minus x plus 4, but times this. So parentheses, 3x squared minus x minus 4 minus x minus 4, parentheses, 2x minus 3, 2x minus 3. So that was the original problem. Now let's see if my answer will match that. 6x cubed, 6x cubed. Get out of cubola mode. Minus 11x squared, minus 11x squared. Minus 5x, was it plus 12? Plus 12. Now, if I don't get the exact same number, something's wrong. Ooh. You could have gotten bonus if you got this right and I got this wrong. What in the world? So 6x cubed minus 11x squared minus 5x. Oh, I got a plus 5x here. Ah, should have been minus 5x, right? Minus 5x. Oh, I hope this is the delete minus. Of course, you got to type it in right. There it is. Matches, matches. They're exactly the same. Ooh, thought I made a mistake. All right, here we go. Lost my pen. So delicious. All right, let's check this out. We're going to multiply again. Product again. So we're going to take this 2x minus 1, and we're going to multiply it by 5x squared plus 3x minus 2. And we're going to double distribute. So 2x times this is 10x cubed. 2x times this is plus 6x squared. And 2x times this is minus 4x. Negative 1 times 5x is negative 5x squared. Negative 1 times 3x is negative 3x. And finally, negative 1 times negative 2 is positive 2. Now I just have to combine some like terms. 10x cubed plus, let's see, 6x squared minus 5x squared is x squared minus 7x plus 2. Again, I don't have my answer key around, and I got to make my answer key tonight, and I haven't made it yet, but I want to get this video cut. So hopefully I'm not making any mistakes. This one is something I haven't necessarily talked about yet, so we're going to have something to fix and or something to work on. And I'll talk about this in class tomorrow, but watch this. I've got 3 roots. So if I was just to write a generic function, I would write f of x is equal to, I'm going to leave some space. I don't know if I need a number in the front. I'm going to put x plus 3, x plus 2, and x minus 1. Now, here's something I haven't addressed in class, and like I said, I got to do it tomorrow. So I'm going to probably make up a couple of example problems for this one. But I said the exact equation. Now, in order for it to be an exact equation, I need to have some number here that makes it exact. Now, I know it's going to be negative. I don't know what it's going to be, but I do know, in fact, whatever number I come up with, it's going to be negative. Now, why do I know it's going to be negative? Because this is a cube root that comes down and goes down here. So it's negative. I just don't know what it is. So if I want the exact value, I'm going to put a C here for constant. Now you're thinking, what the heck? And then I'm going to pick any point on the graph. And my favorite point is probably going to be this one right here. This is the point 0, 6. Now, why did I pick that one? First of all, it's a nice point. Could I have picked another point? Yeah, I could have picked this point. Maybe I'll do both, and I'll show you that if I use negative 1, 4, or I use 0, 6, I should get the same result, hopefully. Let's see. So what I'm going to do is I'm going to type in 6 equals whatever this constant is, 0 plus 3, 0 plus 2, 0 minus 1. So 6 is equal to C times 3 times 2 times negative 1. Or 6 is equal to C times negative 6. Or C is equal to negative 1. Well, that's really boring. That's all it is. So my equation is f of x equals negative x plus 3, x plus 2, x minus 1. Well, that's really boring. I mean, I thought I was going to come up with something a little bit more creative. I knew that. I knew that much. Let me see if it works if I put the other point in there. It should, right? I still should come up with that same exact equation if I use the point negative 1, 4. If, in fact, that is an exact point, which it kind of looks like it is, but I'm not sure. So we're going to put in 4. C negative 1 plus 3, negative 1 plus 2, and negative 1 minus 1. Let's see. 4 equals... this isn't going to turn out exactly. C times... I don't think it is. Oh, maybe it is. That's 2. That's 1. And that's negative 2. So this is 4 equals C times negative 4, or C equals negative 1. Yeah, it worked out twice. So either way, I picked a nice point, plugged in the X, plugged in the Y, and figured out what C is. Sometimes you get like a 2 or a negative 2 or something like that, but it'll be fun. So I'm going to write the exact equation for this one. So I've got 4 roots. Here, 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 and here. So I know my function is going to be f of x equals x plus 5 times x plus 2 times x minus 1 and x minus 3. Now I know this is an even equation, and it also is going to have a negative in the front because it's going down. I'm going to pick this nice point right here. I don't even know if there is another point I could have picked. Is there another point I could pick? That's not exact. I mean, maybe this point. I don't know. But this is the best point right here. This is the point 0, negative 15. So in for y goes negative 15. So negative 15. And in for x is going to go 0. 0 plus 5. Oh, I forgot the c. The constant. That's what my goal is. Like, our goal is to find that c. 0 plus 2, 0 minus 1, and 0 minus 3. So this is negative 15 equals c times 5 times 2 times negative 1 times negative 3. Or negative 15 is equal to c times, that's all positive, positive 30. Divide by 30. Divide by 30, I get c equals negative 1 over 2. So I knew it was going to be negative. I just wasn't sure if it was going to be an actual number. So my equation is f of x is equal to negative 1/2 x plus 5, x plus 2, x minus 1, and x minus 3. And if you wanted to, I know that's by my head, if you wanted to, you can distribute all that stuff out or not. So, based on these graphs, I would like you to be able to tell me whether it's cubic regression, quartic regression, power regression, what's the leading coefficient, positive or negative, what's the degree of the thing. So, best way to do this is probably just to kind of draw a smooth curve. I'm going to draw a smooth curve. So this is clearly odd. It has 2 relative maximins, so it's probably a 3rd degree, which means I want to do cubic regression. Now, it also is going up in that direction, so I know that the leading coefficient is going to be positive. Here, pointing up. Because it's pointing up, I know my leading coefficient is going to be positive. It's got 1, 2, 3 relative extrema, so that means it's more than likely it's a 4th degree polynomial, so we're going to do quartic regression, and it's a 4th degree. So, wow, that's crazy. We got 1, 2, 3, 4 relative extrema. So that means it's probably a 5th degree polynomial. Notice it's coming down, right? So that's going to have a leading coefficient that is negative. So if I had to draw this one, and it's probably this. I know it's coming down, so my leading coefficient is going to be negative. It's only got 1 relative extrema. That makes it a 2nd degree polynomial. And therefore, the regression is going to be quadratic. All right, 2 more. Let's see. Wow, man, these are fun to write. 1, 2, 3, 4, 5. So this is probably a 6th degree polynomial. And my leading coefficient, because I'm pointing up in both directions, would be positive. Ooh, this one's weird. I would go like this. That's a hard one. I mean, you almost could go, I mean, I got 1, 2, 3, 4. So this could be a 5th degree polynomial. But to be completely honest with you, I would think I'm trying to force a curve in there when that's really just a linear function. So I would do linear regression on this one, because I think a line, it doesn't have any clear coming down or going up. I would think a linear regression. So this would be a 1st degree polynomial, and my leading coefficient, because it's going up, would be positive. That's it. That last one, I know you tried to get a curve out of it. It wasn't quite a curve. What the heck am I going to do with this problem? I'm going to drink some coffee. Now I know what to do. All right, let's check this out. Go to the calculator. Got to type that sucker in there. There we go. Let me clear all this crap out. Control, menu, clear. Let's try that again. All right. Come on, get off my screen. All right. So, I got a graph. So let's go to graph mode. And I'm going to type in negative. That's not negative. Let's try to get this in here correctly. Negative 0.05x raised to the 5th. Get out of 5th mode. Minus 0.05x to the 4th. Get out of 4th mode. Plus 1.5 plus 1.5x cubed. Get out of cube mode. Plus 1.6 x squared minus 8x. Whew. Negative. Let's go. Let's go. Enter. What the? Yes! What a cool graph. Oh my God. Now this is an odd function, correct? Yeah, it's really odd. Oops. Let me blow this up. View. So this is an odd function. That means it's going up here and down here. Wait a second. Was my leading coefficient negative? Yeah, my leading coefficient here was negative. So I know that it's going to come down and up. Now I need to find all of the maximums and minimums, don't I? So that's, whatever. So what I got to do is I got to change these. So I'm going to double click on this, and I'm going to change this. I'm going to change this to 20. And then I'm going to hit tab, 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 tab. That's good enough. But wait a second. I still can't see this one up here, can I? So I'm going to hit and maybe make it 50. Now I can see them. So now I can see them all. So I need to find all of the max and mins. Let's put this up here. All right. So menu, analyze graph, 0. Negative 4. Now that was a minimum, right? So negative 4, 0. I think there's a way. Menu, geometry. I know there's a way. Doc. Thought there was a way. I know there's a way. Menu. Whatever. Let's just go analyze graph. 0. Click. Click. Oops. Shoot. Menu. Analyze graph. I'm looking for a max. Did I look for a 0 here? I guess I looked for a 0 here, but it's a minimum anyway. Let's go menu, analyze graph, maximum, click, click. There's another maximum. And we got one more minimum. Menu, analyze graph, and a minimum, click, click. All right, so I got them all. Let me finish with the other minimum. 1.07, negative 5 so 1.07, negative 5.03. 1.87 and 11.3. 1.87, comma, 11.3. Obviously, it said round to the tens place. Should have said probably hundreds place, whatever. And 4 and 25.6. And the other one is 4 and 25.6. So to make these round to the tens place, I guess this should be 9. And this should be a 0. All right. Oh, and this should be a 1. All right. So net 1.1 and, but, you know, it looked like this. Something like this. It had, so notice it's the 5th degree polynomial. How many roots did I have? 1, 2, 3, 4. I could have 5, but here I got a jumping off point. I got a bounce point. All right. Given the following, now this is really important. It doesn't look like it's really important, but it's really important. 6th degree polynomial. If it's a 6th degree polynomial, it can have 6 roots. I have 1, 2, 3, 4 real roots. That means there are 2 imaginary roots somewhere in there. All right. Factor completely. Okay. It's got 4 terms. We're going to group. And I can take out a 9x squared. As soon as I see a 9x squared, I'm already ready for difference of perfect squares. I know it's got to be coming. This is x plus 5. Copy over the minus. Between these two, I can take out a 4. X plus 5. The reason it's plus 5, for 2 reasons. I want these parentheses to match. But the second thing is you take out a negative 4. So my parentheses are x plus 5 and 9x squared minus 4. Now, that's not factored completely until you factor that difference of perfect squares. So you leave the x plus 5 here, but this is going to go to 3x plus 2, 3x minus 2. So if you're waiting for me to do this next problem, you should try it on your own. If you're sitting there waiting, you should try this on your own. Press the pause button. Try it on your own. All right, we're going to group. Hopefully you're here and you've already tried it on your own. I can take out an 8x cubed. Oh my goodness, those are perfect cubes. Wonder what's coming up. Let's see. Maybe not. Oh, whoa, let's back up the crazy train here, Krause boy. Look what we got here. If you look at the whole thing, I got a GCF that can come out of all of it. And I need to factor that out. In order to factor completely, you need to take the GCF out first. So I can take out a 2x. So I'm left with 4x cubed plus 6x squared. Oop, not 6x, 12x. 12x squared minus 25x minus 75. All right, now we're going to group. So I'm going to group these two, and I'm going to group these two. So let's see what I can pull out. Out of these two, I can take out a 4x squared. That's screaming difference of perfect squares already. And I'm left with x plus 3. Out of this one, I can take out a 25. There's another perfect square. I can take out x plus 3. So, come up here. Leave the 2x. My first set of parentheses is going to be x plus 3. My second set is going to be, get rid of these, it's going to be 4x squared and minus 25. But this is the difference of perfect squares, so you got to keep going. 2x, x plus 3, 2x minus 5, 2x plus 5. Holy crap. Lots of stuff. All right, we got cubes. So we're going to be looking for cubes. So First rule is always, can you take out a GCF? And I believe these things have a 3 in common. Okay. Now this isn't too bad. It's a little tricky, but it's not too bad. So what I'm going to do here is deal with this. This is 2m cubed, and this is just n cubed. All right, now we're ready to rock and roll. Now the easy part comes. 3, binomial, trinomial. Copy over the sign, change it. Last one's always positive. So in the first one goes these two things. Nothing, no sign, or no exponents, just those two things, 2m and n. In this one right here is going to go 2m squared. That's 4m squared. In this one is going to go this thing squared, n squared. And in the middle goes the product of the two things. You're going to multiply 2m times n, which is just 2mn. And there's your answer. So what can I take out of these two? Well, it's clear I can take out a 2, and I think that's it. So we'll take out a 2, and I'm left with 27. Yep, that's a perfect cube. K cubed plus 125. Yep, 125. That's a perfect cube. By now, you should start to recognize those, kids. This one is 3k cubed. This one is 5 cubed. All right, you ready to rock and roll? Bring the 2 out front. Binomial, trinomial. Let's get the signs in there. Copy over the sign. Keep the sign. Change it. Last one's always positive. All right. So in the first one, goes to 3k. In the second one, 5. Square them to go here. You square them. Square this. 9k square. Square this. 25. And in the product, in the middle, you're going to multiply the two of them together. 3k times 5, which is 15k. All right, that wasn't too bad. All right, so just skip this problem. There's like 4 sentences and everything. Who can do that? So the volume formula of a pyramid is 1/3 length times width times height. If the length of the base is 3 meters longer than the width, and the height is 6 meters longer than the width, so we want to say let x represent the width. All right, so x is the width. The base is 3 meters longer than the width. Excuse me, the length of the base is 3 meters longer than the width. So longer would be x plus 3. The height is 6 meters longer than the width. X plus 6. So it says express the volumes. If the width is 5, what is the volume of the pyramid? What? I don't think this was supposed to be in here. Let's get rid of that. It says write the equation with no parentheses. So volume of x is equal to 1/3 x times x plus 3 times x plus 6. So volume of x is equal to 1/3 x times x squared plus 9x plus 18. All I did was double distribute these two things. Now I'm going to distribute that 1/3. So volume of x is equal to 1/3 x cubed plus 3x squared plus 6x. So then the question says, what is the volume if the width is 6? So volume of 6, they're giving us width, is equal to 1/3 6 cubed plus 3 times 6 squared plus 6 times 6. I'm grabbing the calculator. I don't need you, I need you. So 6, control var x, hit enter. And what do we got? 1/3 third x cubed, get out of cube mode, plus 3x squared plus 3x squared plus 6x equals 216. Volume of 6 is equal to 216. All right, there we go. That's it, kids. Well, I don't even know if I'm right. I want to know if I'm right. So if this is 6, this would be 9, and this would be 12. So I should be able to do 1/3 times 12 times 9 times 6. So 1/3 times 6 times 9 times 12. Hopefully this is 216. Yay, it's 216. All right. Simplify the following expression. Oops. Missing a parenthesis there. Wow, what am I going to do with this thing? This is a weird one. I'm trying to think if I should do this one way or another. Here's what I noticed. I noticed that they both have this in common. So I'm going to factor that out, and I get 2 minus m times this minus this. 10 minus 3mn minus 10 plus 3mn. So that's 2 minus m times 10 minus 3mn minus 10 minus 3mn, which is 2 minus m times, these cancel, negative 6mn. So for a final answer of negative 12mn minus plus 6m squared n. But that's really weird. Maybe I don't know what that was. Let's see if I can get it right. Let's see if I get the same result doing it a different way. I'm going to double distribute this. So I get 20 minus 10m minus 6mn plus 3m squared n. Nothing I combine there. Minus, I'll do this one a different color so I don't bump into that. 20 minus 10m plus 6mn minus 3m squared n. All right, let's see what we got. So 20 minus 10m minus 6mn plus 3m squared n minus 20 plus 10m minus 6mn plus 3m squared n. 20's canceled. I got negative 10m and positive 10m. Negative 6mn and negative 6mn is negative 12mn. Positive 3m squared n, m squared, so that's plus 6m squared n. So I get the same result. Either way, get the same result. So let's see, this is x squared minus 4x plus 20. If I double distribute this, now this is minus, so I got to double distribute this thing. So that's 4x squared minus 12x plus 9. Now some of you are probably wondering where I got that from. 2x minus 3 times 2x minus 3. That's 4x squared minus 6x plus 9. Plus, this would be 4x squared plus 12x plus 9. Lots of weird stuff going on here. So now I got to distribute the negative. So x, and this is the hard part. You got to distribute this negative. X squared, you can't do it here. You got to do it here. X squared minus 4x plus 20 minus 4x squared plus 12x minus 9 plus 4x squared minus 12x plus 9. What am I doing? Why am I changing these signs? These are signs that are staying the same. Plus and plus. So combine like terms. I got an x squared minus 4x squared. Plus, these cancel. So I get we get x squared minus 4x, 24, so plus 20x. And then 20 minus, no, these cancel. So I got plus 20. Now I really, because I did that so fast and weird, I'm not sure if this is right. So I'm going to go back to my calculator. And I think I've still got some 2.13. Oh, I got 6. So let's go 2.13. I don't like using normal numbers when I check. I'm at 2.16. So I'm going to type in the original. Parenthesis, x squared minus 4x minus 20 plus 20, doggone it, plus 20, parenthesis, minus, parenthesis, 2x minus 3, parenthesis, squared, plus, parenthesis, 2x plus 3 squared, plus 3 squared. Enter. Weird answer. X squared plus 20x plus 20. X squared plus 20x plus 20. Now, I have no idea if I'm right. I really don't. I don't have the answer key around. I'm hoping that those match. Yes! If those match, I'm good. I start. Done with that problem. Okay? So, here's the problem. A lot of kids think they're just going to cancel this stuff out. You can't do that. These don't just cancel, and you can't distribute this negative. You have to actually, this is a real pain in the neck, this question. It looks really easy, but it's not. You got to do 2y minus 5 times 2y minus 5 times 2y minus 5 minus 2y plus 5, 2y plus 5, 2y plus 5. Holy crap. That's a ton of work. I'm not going to lie. This is a pain in the maverick right here. So we're going to double distribute this first one. So I get 4y squared minus 10 is minus 20y plus 25 times 2y minus 5 minus, I'm going to double distribute these two, 4y squared minus plus 20y, because this is 10 and 10 again, so plus 20y plus 25 times 2y plus 5. Now I'm going to triple distribute this stuff. Holy crap. 8y cubed minus 20y squared minus 40y squared minus plus 100y plus 50y minus 125. Yeah, right. Minus, now that's going to be all that same stuff. 8y cubed plus 20y squared plus 40y squared. This should be a 8 and 20. This should be 40. That should be 40y squared. So 40y squared plus 100y plus 50y plus 125. But because I got this negative here, all of these are getting their sign changed. Negative, 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 and negative. So 8y cubed and negative 8y cubed cancel. Now, here are my y squareds. This is negative 60y squared, and this is negative 60y squared. So that's negative 120y squared. This is 150y. This is negative 150y. Those cancel. This is minus 125. This is minus 125. Minus 250. Now that appears to be the right answer, but I'm not going to lie, I think it's wrong. I think I screwed up somewhere. Not going to pull any punches. I think I screwed up. 2.313, control var y. Parenthesis, 2y minus 5, parenthesis, cubed, minus, parenthesis, 2y plus 5, parenthesis, cubed. And then I got negative 120 y cubed minus 250. Yeah, I knew I screwed up somewhere. Son of a gun. Where did I make my mistake? I think I found my mistake. Took me a couple seconds, sorry. I put a cube in here. It's only supposed to be a squared. Why did I put cube? Squared. Enter. There it is. Negative 794, 428. So I do have the right answer. Whew. That was crazy. Sorry about that. Man. It took me a few minutes to find out. I'm like, I didn't make a mistake. Sorry. All right. So I'm giving you a root. I'm asking for the other roots, and I want you to use long division. If this is a root, then it means it came from the parenthesis. It came from the parenthesis x minus 3. So that is the factor that's going to divide evenly into this. So 2x cubed plus 3x squared minus 45x plus 54. So your job is to divide that into there evenly, and then when I'm done, I should end up with a 0 at the bottom. So how many times is x going to 2x cubed? Oh, 2x squared. We're going to multiply by both of these. 2x cubed minus 6x squared. Subtracting is the hardest part, everybody forgets it. Minus, plus. 9x squared, bring down the minus 45x. What do I have to multiply x by to get 9x squared? Oh, plus 9x. Notice this would be squared, this would be 9. Next one won't have a 9 at all, or an x at all. So 9x times both of these is 9x squared minus 27x. Don't forget, we're going to be subtracting. Subtract, add. So 45 minus 27. So this would be negative 18x plus 54. What do I have to multiply x by to get negative 18x? Minus 18. Negative 18 times x is negative 18x. Negative 18 times negative 3 is 54. Mailman's coming or something. Subtract, plus, minus, and there's my goose egg. But I'm not done. So what I have here is x minus 3, and if I multiplied it by this, 2x squared plus 9x minus 18, I would end up with that. But I want the other roots. That means I have to continue to factor this thing. So 2x and x. So I have to find a way to multiply to 18 that adds up to 9. So let's see. I'm going to try 6 and 3. There's 12, and there's 3. Ooh, I got it. So plus and minus. That's weird. So x equals 3 over 2 here, and x equals negative 6. So my two answers are negative 3 over 2 and negative 6. So once again, I'm giving you a root. I expect you to find the factors. Okay, so the factor for this one is x plus 2. 10x cubed minus plus 9x squared minus 28x minus 12. Woo! So what do I have to multiply x by to get 10x cubed? 10x squared. 10x squared plus 20x cubed plus 20x squared. Subtract. So I get negative 11x squared minus 28x minus 11x minus 11x times x is negative 11x squared minus 22x. I'm going to subtract. This turns into a plus. This turns into a plus. I end up with negative 6x minus 12. I'm going to multiply by negative 6. Negative 6x minus 12. Subtract. And end up with goose egg. But this has to be factored over here. Don't forget to do that. 10x squared minus 11x minus 6. If they ask. All right. Not the greatest factoring. I'm going to guess it's probably 5x and 2x. And with this one, I'm probably going to guess that it's 3 and 2. And since I can't put the 2 here, I'll put the 3 here and the 2 here. Let's see. That's 15 and 4. There it is. Minus 15 and plus 4. So my answers are x equals negative 2/5 and x equals positive 3/2. Negative 2/5, positive 3/2. This one is not asking for roots, it's asking for factors. So when I'm done, I'm done. Well, sort of. So I'm going to divide x plus 1 into 6x cubed plus 43x squared plus 82x plus 45. Now, at first, it seems like, oh my God, they're ginormous numbers. No way I'm going to get it. You just have to be very careful of your signs. I'm going to multiply by 6x squared. That's 6x cubed and 6x squared. Subtract. Be careful with the subtraction. Subtract, subtract. That's going to be 37x squared plus 82x. So plus 37x. 37x times x is 37x squared. 37x times 1, 37x. Subtract and subtract. Let's see. 82 minus 40 would be 42, so this is 45. And I need a plus 45 at the end. 45x plus 45. Subtract. And I get goose egg. Luckily for us, this unit, they're all going to turn out to be goose egg. Later on, not so much. So we have to factor this thing. We still need to find the other factors. This is one of them. I want to find the other factors. So let's see. I'm guessing, I'm going to start by guessing 3x and 2x. Now for 45, I'm probably going to guess 5 and 9. But I can't put the 9 here, so I'd have to put the 5 here and the 9 here. And I know that both signs have to be plus. Let's see, that's 45 and that's 10. That ain't going to do it. That is not going to do it. So I can't put the 9 here, so that didn't work. All right, I'm going to try one more thing. I'm going to try 3 and 15. I can't put the 3 with the 3, and I can't put the 15 here. So this was wrong altogether. Can't be right. So now we got to go to 6x and 2x. And now I'm going to go back to 5 and 9. Let's see. I can't put the 9 with the 6, so the 9 would have to go here. And the 5 would have to go here. Let's see. That's 54 and 10. Nope. That ain't going to work. So let's try 3 and 15 again. Now I can't put the 3 here. I can put the 3 here. And I can put the 15 here. I must have messed up. I still think it's 2 and 3. So let's go back to 2 and 3. 2x and 3x. And I'm going 5 and 9. 5 and 9. Let's see. 9 and 5. Oh, what the heck was I doing? What did I do before? I'm going to have to go back and look what I did. Here's 10. And here's 27. That's 37. So both plus. So 10 and 30. I don't know what I was doing. So this is x equals negative 9 over 2 and x equals negative 5 over 3. So those are my answers. Negative 9 over 2 and negative 5 over 3. Sorry about that. I don't know what. I got a little brain fart there. Okay, so I went back. I made a mistake. I saw what I did. I went like this. I said, oh, 3 times 9, that's 45. What? What? 27. I did 9 times 5. Okay, off that, onto this. All right. So, yeah, we haven't done these in a while. First things first, we got to isolate the weird things. So we're going to multiply both sides by 3 and get the weird. Oh, I didn't see that 5 there. I thought that 5 was under. You got to move that 5 over. You got to take care of your adding and subtracting first. So, x to the 4th minus 10x squared plus 18 equals 1. Now I'm going to multiply both sides by 3. So now I have isolated the weird thing. X to the 4th minus 10x squared plus 18 equals 3. To get rid of a radical, we square both sides. So hopefully I write this better. X to the 4th minus 10x squared plus 18 equals 9. We'll bring the 9 over. X to the 4th minus 10x squared plus 9. We will factor. Oops. X squared minus 1. X squared minus 3. Excuse me, 9. Each of those is the difference of perfect squares. So this is going to be x plus 1, x minus 1, x plus 3, x minus 3 equals 0. So I get 4 answers. Plus and minus 1, plus and minus 3. However, since this is a radical, you must check those answers. And yes, I know it's a pain in the neck. All I got to do is stow them and check the left side, though. Don't worry about that equals. We'll see if they equal 6. So let's take, and it really drives me crazy that. All right, let's do it this way. Let me zoom out of this thing. I got this thing zoomed in way too much. All right, so negative menu. Menu. All right. Let's stow. Negative 1 control var x. And we're going to type this in. Control division. 1 divided by 3. The square root of x to the 4th. X raised to the 4th. Now we only got to put this in once. It is kind of a pain in the neck. 10 x squared plus 18 plus 5. And hopefully we get 6. Yay! All right, so we're going to do 1 control var x. Typed it. Hopefully we get 6. Yay! Now we're going to do negative 3. Negative 3 control var x. Hopefully we get 6. 6, yay, 3, control var x. Hopefully we get 6. Yay! Okay, so in this case, they're all correct. They all work. That doesn't always happen. I'm certain one of these is not going to be correct. We'll see. So, let's get going. We're going to subtract 10. So I get negative 3 square roots of all this crap. My 4s are terrible, aren't they? Equals negative 18. Divide by negative 3, and I get the square root of x to the 4th minus 17x squared plus 52 is equal to positive 6. We're going to divide both sides by negative 3. Square both sides, and I get x to the 4th minus 7x squared plus 52 equals 36. We'll subtract 36 from both sides. Goodbye, goodbye, so long, farewell, auf Wiedersehen, good night. What the heck is wrong with me? 14, 16. So plus 16 equals 0. Factor. X squared. X squared. Let's see. What multiplies to 16 that adds up to 9? 4 and 4. That ain't going to do it. Oh, 8 and 2 doesn't do it. I am such an idiot. I knew something was off. Here it is. I knew it wasn't going to factor, so I'm like trying to figure out what I missed. It's a 17. So this should be minus 1, minus 16. Sorry about that, children. Okay, so this one, hopefully by now you realize you're going to get plus and minus 1. This one I know I'm going to get plus and minus 4. Now you can factor this to x plus 4, x plus minus, x plus 1, x minus 1, x plus 4, x minus 4. But those are your answers. So plus or minus 1, plus or minus 4. Now, we still have to check them. I know this is a pain in the neck. So go to your calculator. So negative 1 control var x. And we're going to type in negative 3. You got to type in the exact beginning times the square root of x raised to the 4th minus 17x squared minus 17x squared plus 52. Plus 10. And hopefully this is negative 8. Yay! Now we're going to do 1. Control var x. Enter. Negative 8. Now we're going to do 4. Control var x. Wow, they're all going to work. Negative 4. Control var x. Seriously? That's weird. All right, hopefully this one will work. Man, I got plus 10 again. Okay, we're going to subtract 10. I'm going to speed things up. Subtract 10, that's 35. Divide by 5. So I get x to the 4th minus x squared minus 23 equals 7. I'm going to square both sides. Square, square. I get x to the 4th minus x squared minus 23 equals 49. Bring the 49 over. I get x to the 4th minus x squared minus, what the heck? Was that 72? I think it's 72. Equals 0. So I get whoosh, 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 whoosh. X squared minus 9 plus 8. So this one's going to be weird. So I'm going to finish this one. X squared plus 8, x plus 3, x minus 3 equals 0. So this one I get x equals negative 3. This one I get x equals positive 3. This one I'm going to get x squared. Let me do it right here. X squared plus 8 equals 0. X squared equals negative 8. X equals plus or minus the square root of negative 8. But I know the square root of negative 8 is really negative 4 times 2, which is x equals, x equals plus or minus 2i square roots of 2. Wow, that is going to be weird. So let's see what we got here. So I'm going to store, let's store the easy ones. 3, control var x, enter. And we got 5 times control square root x to the 4th minus x squared, x to the 4th minus x squared minus 23 plus 10, enter, 45. 45, good. Let's try negative 3. Negative 3, control var x, enter. 45, good. Now we're going to do 2 times I square roots of 2, control var x, enter. Hopefully this is 45. Yes. Now I don't want to type that crap back in. So I'm going to do the negative of this. Negative. And then I'm going to go. Wow. All 4 of those were answers too. That's craziness. So plus or minus 2i square roots of 2, comma, plus or minus 3. So the following graph shows the temperature in Aspen, Colorado during a 48 period beginning on midnight Thursday, the 21st. So this is 12 o'clock a.m. 12 a.m. Midnight. Right here. We can model the data shown with a polynomial function. What degree polynomial should we use? Wow. Let's see. What do you think? It was higher here, probably coming down like this, maybe? So maybe this is a min, max, min, max. Looks like it's going down this way and maybe up this way, maybe a little bit. So I would say, I think that the degree of this polynomial should be, let's see, 1, 2, 3, 4, a fifth should be, I think that this polynomial should be a 5th degree polynomial, since it appears to have 4 relative extrema. And it appears to be odd since it goes up and down in opposite directions. Now, if you didn't argue that this went up and this went down, but instead your argument says, well, it looks like, well, I'm not sure what we do here, but maybe you say it looks like it goes down here and then it goes down here, then maybe you could say it's an even function with a 1, 2, well, this wouldn't be a polynomial. This wouldn't be polynomial. Well, this would be, I don't know. That would be a harder sell, I guess. But if you said that, you could say it's an even function with 1, 2, 3 extrema, and maybe it's a 4th degree polynomial. Let t be the function that represents this temperature. If we let t equals 0 correspond to midnight, interpret the meaning of T5. T of 5 is the temperature at 5 a.m. on January 20. Oh man, this should be say. This should be say. I guess this should say Thursday the 23rd, because this says Thursday, January 23rd and January 24th. So I think that date's wrong. On Thursday. January 24th in Aspen, Colorado. All right. Next one says, what is T of 5? Well, T of 5 is 13 degrees. What are the relative max and min and interpret their points? Well, I would say this is a relative min. This is a relative max. This is a relative min. This is a relative max. And so you would have to just explain this, but my relative mins are, it looks like at, let's see, 6, 7, at 7 a.m. on Thursday, we had a min, so the lowest temp in this interval. So like in the morning on the 13th, in morning of the 23rd. And it had its coolest temperature, or it's down here at like 5 a.m. So at, oh, so that's the tool. Actually the coolest temperature of the whole day. So this represents midnight on this day, right? So this represents the coldest temp on Friday, the 24th. Did it say relative extrema? Oh, what are the relative maximum points? Whoa, let's back up the crazy crane there, kid. So the two maximum points are clear right here. Here and here. And what they represent is the highest temperature of the day. This is the highest temperature on Thursday. It occurred at 1 p.m. So you would have to say at 1 p.m. on Thursday, it had its highest temperature of what looks like it might be about 28 degrees. Maybe 29 degrees. On Friday, January 24th at 1 p.m., we had the highest temperature of around 34 degrees. And that's what you'd have to say there if you were interpreting that graph correctly. All right, so what are we going to do here? I think we clearly have a cubic function. It's going in opposite directions. So when I'm done with C, C better be negative. But the cool thing is we do have a really nice point. Maybe we can use that point. You know what? I don't think that point's going to be that useful. Because if I plug in 0, this whole thing goes to 0. So I could plug in 0, 0. So I plug in 0 for this. And I plug in 0 for r, I get 0 cubed minus 72.25 times 0. So I get 0 equals c times 0, and I get 0 equals 0. But that doesn't tell me what c is. So that really isn't a very useful point. So I need to find a very useful point, and I'm going to pick this one. I could pick this one, but that's negatives, and this one's positive. This is the point 5, 800. So I want to find out what C is. So in for V, I'm going to put in 800. I don't know what C is. In for V, I'm going to put 5. So 5 cubed minus 72.25 times 5. So 800 is equal to C times, I don't know what that is, 125, that's 5 cubed minus 72.25 times 5, negative 236.25. Negative 236.25. Divide 800 by that. 800 divided by I thought this worked out nicely. -72.25 negative minus 72.25. So, where's my mouse? 125 minus 72.25 times 5. 125 minus 72.25. Okay. So negative 3.86. Let's round it. So C equals negative 3.8624. 38624. 38624. I probably should have told you what to round to. If I told you to round to the hundreds place, then C would be equal to negative 3.89. No. Hundreds place. Negative 3.9. Negative 3.39. Boom. There it is. Hundreds place. All right. Almost done. All right. So the owners of Dizzy Lizzie's an amusement park are studying the wait time at their most popular roller coaster. The table below shows the number of people standing in line for the roller coaster T hours after Dizzy Lizzie opens. Jalon made a scatter plot, decided that a cubic function should be used to model the data. His scatter plot and curve are shown below, or to the left. Do you agree that a cubic polynomial function is a good model for this? What information would Dizzy Lizzie be interested in learning about from this graph? How can they determine the answer? So, is the cubic model a good one? I don't know. You know what I'm going to do? He decided a cubic. I don't know. Let's see. You know what I want to do? I'm going to go look at the data. So I'm going to go. I actually typed all of it in. And let's see. We're going to go doc, insert, data, and statistics. And there it is. Click. On the bottom goes hours. And on the top goes people. I don't think a cubic model is a good model for this one. I think this would be a quadratic model. And if you look at it, I'm not sure why, but he graphed this thing. Yes, this thing, whatever this thing is to the left, looks like a good quadratic. It looks like a good, I guess this looks like a good cubic model. But I don't use any of this information down here. So I would say no. The data points that he actually plotted represent more of a quadratic model rather than a cubic model. What would I be interested in knowing? Well, what I want to know is, so check this out. These are the wait times after the roller coaster was open. So what do I want to find out? I want to find out when is the best time to go to the roller coaster. And it looks like maybe at the beginning or at the end of the day. But during the middle of the day over here in this area, it looks like there's lots of people in there. Estimate the wait time. Estimate at which the line, at what time the line is the longest. So what I want to do, use the t-intercepts to write the function. This is an interesting question. I probably should have done this one beforehand. Estimate the wait time. At the wait time is the longest. Well, it looks like it's somewhere right here. I'm going to grab my pen. It looks like it's right here as the wait time is the longest. So that's somewhere between 4 and 7 hours. That's 4 hours, that's 7 hours. So I would say at approximately 6 hours after the park opens. Estimate the number of people in line. Estimate the number of people in line. About 6 hours after they open. It looks like it's a little bit, so I'm going to say about 360. So I'm say about 360 people. Estimate at the time at which. Now I don't give you the time the park opens, right? So the only thing you can say for this one is 6 hours after opening. We think there's approximately, oh, this one. This is 6 hours. This would be 360 people, and my explanation would simply be that is the maximum point. The maximum point is 6 hours after they open, and it looks like there's 360 people. Estimate the t-intercepts of the function used in this model. So the t-intercepts are going to be 0. And let's see. That thing represented 12, so this may be so this looks like it's 13, 0. So the t-intercepts are t equals 0 and t equals 13. Use the t-intercepts to write the formula for the number of people in line. So P of t is equal to t times t minus 13. Or in other words, t squared minus 13t. Remember, these are the roots. I would just leave it like this. This is fine. Perfect. Use the maximum point to find the leading coefficient. So the problem with this is, and you need a better model is, you should have P of t is equal to some constant times t plus t minus 13. I just don't know what this constant is, but I'm going to use that point 6, 360 to see if I can figure out what that constant is. So in for P of t, I'm going to put 360 is equal to c times 6 times 6 minus 13. So it should be negative. So this is 360 equals c times, let's see, this is 6 times negative 7, negative 42. So c is equal to 360 divided by negative 42. So negative 8.57. Negative 8.57. Now I would expect it to be negative because the parabola is coming down. So C would be that. So what would be a reasonable domain for your range? Domain. My reasonable domain would be from 0 to 13 hours. Because it looks like the park closes after 13 hours. So whatever time they open, they're going to open for 13 hours because the line is 0 at 13 hours. The only way the line is going to be 0 for a roller coaster is if there's nobody in line. Your park's closed. Use your function f to calculate the number of people in line 10 hours after the park opens. Okay, so we're going to do P of 10, and we came up with, what was that number? Negative 8.57. Negative 8.57 times t, well, in this case, times 10, times 10 minus 13. So, negative 8.57 times 10 times 10 minus 13. So using this, we're going to estimate 257 people. So P of 10 is equal to 257 people. Let's see if that's right. 10. We came up with 180. That's crazy. It's way off. Maybe it's not a great model. Compare the calculated value with the above value and explain your data. So it's really far off. It's way off. It's like 60 or 70 people off. So remember, these are only estimates. I wonder if I had actually used that whole value, would I have gotten a better estimate? So if I use this whole thing, enter, times 10 times parenthesis 10 minus 13. I wonder if I get a better answer. 259, it's about the same. It's not going to change much. So still, it's not a great model. So write a cubic regression model for the data. All right, so we're going to use the cubic regression model. So maybe the quadratic model, what the heck am I doing? Maybe the quadratic model was not good enough. So we're going to go over to the calculator, and we're going to go back to our spreadsheet. Oops, we're going to go back to our spreadsheet. And we're going to go menu, data, Menu, menu, statistics, stat calculations, and we're going to do cubic regression. Hours and people. So, let's see if a cubic would be a better model of this thing. So, I get P of T is equal to, now A equals, B equals, and C equals. A is, I'm going to get D2, 0.37, 0.3745, does it say rounding? 0.37456, B is negative 16.607, negative 16.607, 823. C is 153.03, 153.03, 708. And D is negative 21.25, negative 21.25, 329. So my equation, let's say we round to the hundreds place, is 0.37x cubed minus 16.61x squared plus 150.30x minus 21.25. There's my quadratic. Graph your function from H and your regression model to complete the table. Wow. So what I did was, while I was on a pause there, I went through, I should have copied these over. I could have copied these over as well. The original problems were 0, 75, 225. Man, this is a pain. 0, 75, 225, 345, 355, 345, 355, 310, 180, 310, 180, and 45. And then what I did was I put both equations in my calculator. So if you look, the red equation was my original one that's a quadratic, and the black one is the regression equation that I came up with. You'll notice that they look really, really similar. Now, of course, the black one's going to come back up while the red one just keeps going down, but they look really similar for the data pieces that are important, these pieces here. And sometimes, even though it looks like a quadratic will model the behavior better, maybe a cubic is actually a better model. So what we're going to do is we're going to go to our equation. So red is the cubic, or red is my original, so Control T. And I'm going to go through red. So 00103, I'm going to do this, 00103, 189, 257, 189, 257, 309, oh wait, hold on, we didn't have a 3. 2 was 189. And 4 was 309. And 7, 360. Wow, that's pretty good. 8 was 343. 9 was 309. Oops, 10. 10 and 12. 10 was 257. And 12 was 103. So not great. G. So 12 was 30. 10 was 191. 8 was 308. 7 was 344. 4 was 338. 2 was 216. And 1 was 113. And this was actually negative 21. So, based on the results from the table, which model was more accurate at time 2? Well, time 2, this one's more accurate, and time 10, this one's more accurate than this one. So, the answer would be the regression equation. And that's it, kids. That's all she wrote. Just an idea of how to use a regression. Even though the data looked quadratic, maybe an cubic curve restricting the domain would be a better answer. So that was a tough question. We'll probably talk about that one in class. All right, take care, buddies. See ya. Catch you on the flip side. Goodbye. I don't know where to stop this thing.